funny. Actually, my messages did fill up about an hour earlier, and I missed a text. I had to empty a bunch out.
Well, if anybody can screw up an electronic device, David, it's me. So.
Now, you didn't by chance get a confirmation email that said it was at 5 o'clock, did you? Or 7 o'clock? Was it off by an hour?
You know, what it was is it actually was, I got one that just came in like an hour ago confirming today's, and I thought it was confirming something different because you sent one yesterday confirming today.
Right.
So I thought that you were confirming some new meetings we hadn't booked.
Okay, but everything is okay with those confirmation emails? Because I don't ever see those. I don't send those out. Those are sent out by the software that I use for the automatic scheduling.
Yeah, it's sort of odd because I usually don't get them just 1 hour before. I usually get the confirmation right after we make it, and then of course we get the number a few minutes when you send that in.
Huh,
so
okay.
I don't know whether the software just had a glitch and resent them out again or what.
Yeah.
No big deal. Okay.
So, Patrick, we left off, I believe, at 51.
Yep.
And let's take a look at 52 here.
All right.
They're giving us a bunch of data points, and they want us to make a graph. Now, they're not giving us a function, which means they're not giving us a smooth line. It's just data points. Okay? So, they want us to do various things. Start by labeling the axis, provide a consistent scale, and so forth and so on. They say do it on engineering paper, but for our purposes, we'll do it right here. Tell me what let me erase this, make it a little bigger. What should the horizontal axis be?
It should be hours studied.
Okay. And the vertical axis?
And score.
Which we'll also call the y. And if by a consistent axis, they don't mean the x-axis has to be the same as the y-axis, or they don't mean that the grid system has to be the same. In other words, it would be acceptable if I made that 1 and I made this 10. Consistent, what they mean is that once I've decided to make that 1, then that has to be 2. Once I've decided to make that 10, that has to be 20. You know what I'm saying? In other words, I can't now put a point there and call that 10. That would be inconsistent with the rest of the x-axis that I've created. So that's all they mean. So let's wait to label these until we know some of the values. Well, the first value, let's just take the first column and go column by column, left to right. Where do I make my first point? What's the x-coordinate? What's the y-coordinate?
7.2 and 23.
Okay. And if I scan the various range of the x-coordinates, I can see that we go from 1 to 10. So let's make it from 1 to 10. Now I'll just divide that thing up in half. So that's 5. That would be 2.5. So that would be 2. That would be 7. There we have a consistent x-axis. And the consistency isn't based on where I chose to label it. Notice that I labeled the 2 and I labeled the 5 and the 7. Well, that has nothing to do with the consistency. The consistency is based on this much grid between there and there is equal to 1 everywhere along here. Okay? The y-axis. What range of numbers do we need to account for?
between 5 and 25.
Okay, so
5.
yeah. Oops, that would have been inconsistent. We'll start there. So now let's start making some data points. And we don't have to go in order of size. We can go in the order that we see here. So let's do this one first. So I'm going to go over to where's that point go?
It didn't show up, David.
No, I
You're asking him for
haven't
the
made it yet.
fifth
Before I drew it in there, I wanted to ask Patrick if he knew where it went.
It would go to 7.2 on the X and then 23 on the Y.
Okay. So I'll approximate these. It's about right there. And I can label that, but it's just going to end up with a bunch of numbers all over my page, and it's not going to be helpful. So I'll do the next one. I think you understand what's going on here.
Yeah.
Now this one is 5.5 is 14. And 1.6 is 5. 1.6 is about right there. You don't suppose they're trying to tell you anything with this table, do you? 8.2 is 22. Now notice that 8.2 is actually less than 7.2. We're not done yet. 4.4 is 15. And 3.9 is 11. And finally, 6.4 is 17. So you end up with something that looks like that. Draw the line of best fit and identify 2 points from your line of best fit. How do we draw a line of best fit?
Well, don't you just have to draw a line that hits 2 or more points?
Actually not. This is a, you want to draw a line through that set of points that represents the best fit. Now, how that is defined is a very complicated statistical formula. And I've approximated it here. But notice I could tilt the slope of that thing in either direction and I might have a better line. In other words, is that the best line or maybe something that goes a little bit steeper slope? Well, to figure that out, I would have to go to my calculator and have the calculator calculate the perfect line. It's called the least squares linear best fit line. But for purposes of this problem, they don't want you to do that. They want us to approximate it. Well, if I extend my approximation here, it goes right through the origin. What's the equation of this line? Find the equation of the line in slope-intercept format. What's slope-intercept format?
Y equals mx plus b.
Okay, so what would the equation of this line be?
Hold on, I'm figuring it out. Would be 2.2 over 2. That'd be
What's the slope going to be? Well, let's start with the easier thing. What's the y-intercept?
Yeah. 0.
Right. So our equation is going to be y equal the slope times x. So all we have to do is figure out the slope. What's the verbal definition of slope?
Rise over run.
Okay. What's the rise? Pick any 2 points on the line. In other words, you can go, the easiest 2 to pick are probably there and there. But we don't have a point at 10. Nobody studied that much. But we do have a point at 9.2. So we could go to this last point here, which is right there, and we know that exact value is 9.2, comma 25. And the origin is 0, comma 0. So what's the slope? What's the rise?
Going up by 0.8.
To find the rise, we want to find out how far it goes between here and up here. That's the rise. Well, this is 0. What's this value up here? 25. So the rise is 25. 25 minus 0. What's the run? How far along the x-axis does it go? In other words, the run is from here to there.
9 point.
Right. So there's your slope, 25 divided by 9.2. Now, you can convert that to a decimal if you like, so that we don't have a decimal in the denominator. Go ahead and use your calculator to come up with that number. What'd you get? 25 divided by 9.2.
2.7.
Okay. So there is an approximation of the equation of that line. And why do I say approximation? Because for one thing, I drew this by eye. I didn't go in and let the calculator figure out what the perfect fit would be. And for another, I'm basing this on approximations of what I read. In other words, I drew the line, extended it, and then it went through the origin. Maybe it goes through 1 or 2. And it would make sense that it actually has a y-intercept. Wouldn't it make sense? Why? What score would you get if you studied 0 hours?
Probably around a 0.
Yeah, maybe a 0, maybe not. You probably would get a 1 or a 2, I would think. I don't know. This guy who studied 1.6 hours got a 5. So who knows whether it should go through 0 or not. We couldn't tell from our approximation. If you did this thing on engineering paper, you'd have a much more accurate y-intercept. Although you would still have to approximate the slope of the line. In other words, they're not asking you to come up with the perfect slope of the line. All right, so based on our equation, to answer number...
David,
Yep.
Hey, can you hold on to a second?
Sure.
Because Patrick did that rise over run and ended up getting it wrong. He had 22 over 2, so
No, I
2.2 over 2? Okay, so what did you do wrong?
I flipped the x and y axis.
Okay, so it should, because it should be the y goes on the top, right? And the x goes on the bottom?
Mm-hmm.
And you put the x on the top
Yeah.
and the y, okay. All righty, thanks, David.
All
Go
right.
ahead.
All right. So based on this equation that we came up with, if a person studied for 10 hours, what would his score be?
Don't you figure that out? Don't you just plug it in?
Well, what they're really saying, let me reword that. I'm going to change this equation. So instead of its y is equal to 2.7x, I'm going to say f of x is equal to 2.7x. Incidentally, you can always do that. Y and f of x are interchangeable. The advantage of writing it by f of x is I can now say, what is f of 10? Which says, what is the score you're going to earn if you study 10 hours? In other words, if x is 10, what would y be? What's f of 10? If f of x is 2.7 times x.
I'm figuring that out.
You don't need a calculator for that.
So what would it be? Sorry.
It's 10 times 2.7.
Oh, sorry, it'd be 27.
Okay. I don't think you need a calculator for that. You don't need a calculator for that, do you?
No.
I have had students that had to use a calculator to multiply and divide by 10. I kid you not. Okay, so let's estimate the number of hours studied in order to get a score of 50. So how do I solve that? If y equals 2.7x, and x is the number of hours scored, and y is the score you earn,
Once you, well, this is the way at least I learned it. Once you just plug it in, 50 equals 2.7 times x plus 0.
well, yeah, you don't need to add the 0. You just need to do that. In other words, there is no, the y-intercept is 0. We know that. But when they say how many hours would it take to get a score of 50, y is 50. So that's why you plug it in for y. And then if you solve that, now this you will need a calculator for. What's that equal to? That's your answer.
18.5.
Now I noticed that they didn't give us any directions on rounding off or anything here. They just say use your equation to estimate the score. All right. Identify the slope of your equation. What is the real world meaning of the slope? So the slope of our equation is
2.7.
What does that mean in context to this problem?
Would it be for every hour you study, the points goes up by 2.7?
Very good. Yeah, exactly. Your score improves by 2.7 points per hour studied. And identify the y-intercept.
It's 0.
In ours it was, yeah. What's the real world meaning of that?
I'm not quite sure.
It's what you're going to get if you don't study. Like I said. That I guarantee you that you're never going to see this curve go the other direction. They're never going to give you a problem where the curve goes like that. Not in this sense. And in real life. I mean, this reflects real life for sure. It's more than just propaganda. It's also truth. All right. I didn't get this other page. Oh, maybe I do have it in my inbox here. Did you just send it?
No,
Yeah. There is no other.
there is no other page, David.
Oh, so this is the last problem?
Yeah, that was the, you got, what you had right there was the last problem.
52? Okay. I thought it went up to 60.
No, it was 50, just 52 for some reason. That's what they picked.
Okay. So we've covered it all.
You know, there's one thing, I had a couple of things that when Patrick and I were going over the stuff from yesterday that I wanted to actually make sure that he understood again. As far as on these, the slope, the starting on the lower left, going to the upper right.
Okay.
No, I'll stay.
Let me test him.
Yeah, okay.
There's our axis, straight as I can draw them. Just say positive, negative, 0, or undefined.
Negative, right?
No.
Lower left,
Lower
upper
left.
right.
Oh, okay. So
It goes from lower to upper. And we'll always assume that we're measuring this going from left to right. Okay? So anything that goes lower to upper is a positive slope. So let's see. Lower to upper, that comes before this in the alphabet. That's plus. Upper to lower, this comes after L in the alphabet. That means minus. There's various ways to memorize stuff, but I use little tricks like that whenever I can. And notice that if I change it just slightly, it goes from upper to lower. U to L is a negative slope. What's this slope? Patrick, still there? I heard a little beep. I don't know if I lost the audio or not. Try logging out and then logging back in to go to meeting. Hi. My end shows you being offline. Did you try logging out of GoToMeeting and then logging back in? may need to reboot. The next thing to try would be to reboot. If it's not allowing GoToMeeting to connect, it sounds like you might have lost your internet connection. And your other stuff still appears to work, but it may only be an appearance because it's in your RAM. And, oh, okay, now I see that you've left the meeting, so it registered your log out. Now try logging back in before you reboot, if you haven't done it already. Yeah, and if we don't really actually need the audio, I can call back on your speakerphone, and we could do the audio as long as you can see my screen. Now, when you lost me the first time, you lost everything, didn't you? You didn't lose just the audio, you lost, you couldn't see my screen anymore? Okay, okay. Still no go? Yeah, well, go ahead and just reboot and then try to log in with that same meeting ID. I won't, well, yeah, try it with the same meeting ID. I'll hang up because this is going to take your computer 5 minutes to reboot. Okay, bye-bye. Hello?
There came back up, David,
Okay,
now.
so it worked. Good.
Yeah, what is home thing? That's where the screen goes on. Okay, all right, there we are.
Okay. Yeah, that's the downside of technology, I guess. And it takes longer and longer to reboot a computer these days. I notice it takes mine at least 5 minutes to get up and going again.
It's the first problem we've had with this all the time we've been working together, so it's been good.
Yeah. Okay, Patrick, what's the slope of that line?
That's a positive, right? I mean, negative.
Which one?
Negative.
Right, because it goes from U to L. Slope of this line. Vertical line.
It's is it 0?
One of them's 0, one of them's undefined.
The horizontal one is undefined, and the other one's 0.
Which one is undefined?
Yeah, horizontal.
No. Let's remember a way to memorize it.
That's what we're looking for.
Here, let me move my thing out of the way. What's the slope of that?
It's a positive.
What is it? Is it approximately? So 45-degree line is a slope of 1. Okay, so that's m equals 1. Now, the only thing you have to remember to know what a vertical and a horizontal line is what is the slope of that? Is it 2 or 1/2?
1/2.
Okay. So by the time we get to a horizontal line, what is it going to go to? Infinity or 0?
It's going to go to 0?
Right. In other words, as I tilt this thing, that's 1/4. In other words, as we get closer and closer to a horizontal line, we're getting closer and closer to 0. And that's really the only thing you have to know. You don't even have to know the other way. In other words, as long as you remember that this line here is 1/2 and not greater than 1, then you can always figure out that the horizontal has to be 0. And the vertical must be the other thing. Undefined, what else does undefined mean?
It means it's infinite.
Infinite. Infinitely large. In other words, as I look at the other side of this thing, as hard as it is to believe, that is a slope greater than 1, maybe 2. And as I get steeper and closer to the vertical line, the line I just drew might have a slope of 100. And I make it just slightly steeper, not quite a vertical line, almost, that might have a slope of 1,000. And finally, when you get to vertical line, the number is infinitely large. So that they don't even like to call it infinity, they say undefined. All right, I was going to open up the packet, and we could start from the beginning, and maybe you guys can figure out what we should review. Here, let me bring it up. This must be the initial.
Which ones do you think you need most work with? Because it seems like the equations you've got pretty good. I can go over those with you. Is it the polynomial ones, or does it go back to this functions, or the write the equations of a line passing through 2 points? Or which ones do you think you want to work on a little bit more?
How about if I randomly test from the ones we've done?
You know, that sounds like a great idea.
And don't have him looking at, like, if he's got these all solved and everything, have him put that away. In other words, let's see if he can do these that we've already done.
Yeah, I've got a blank set right here, so he can use those.
Okay.
If you can't see them.
Okay, good.
So.
Good. Make these a little bit bigger. How about number 2? And just you know what I'd like you to do, Patrick, is read me line for line. You don't even have to tell me what you're doing, just tell me the next line.
Alright, so you're going to want to times it by 4/5 each side. Oh, I mean, divide it.
What's the next line?
It would be x equals
how do we do this? And I don't do this on your calculator. I mean, some of these you're supposed to be able to do on your calculator, but I want to make sure you know how to do this manually. How do you divide by a fraction?
Don't you turn the other thing into a fraction?
No. You, instead of dividing by a fraction, you flip the fraction and multiply. So negative 16 divided by 4/5 is exactly the same as negative 16 multiplied by 5/4. And what's the answer to that?
Would it be 80 over 4?
Which is?
It's a division.
What's an easier way to do that? I hate to see you keep doing these the long way. In other words, let's look at this process. It is true that that's 80 over 4. But there's an easier way to do that such that you don't have to bring in numbers bigger than 16. How do I do it? How do I reduce it before I multiply?
You put it into a fraction?
No, I don't need to do that. Notice that when you're multiplying fractions, you don't need a common denominator. You just multiply numerators and you multiply denominators. So there's nothing wrong. I can put the 1 under there. There's nothing wrong with what you did. It is 80 over 4, but then you still have more math to do. If we do this little shortcut, you won't have to do any more math. The shortcut is it's the same as writing it like that. We're going to divide. I can take any fraction and divide the top and the bottom by the same number. Why? Because all I'm doing is just multiplying that fraction by 1. Okay? In other words, I can divide the top and the bottom by 4. When I divide the bottom by 4, I get a 1. When I divide the top by 4, I get a 4. Now what's the answer? What's 4 times 5?
It's 1.
That's it.
So it'd be...
The bottom is 1, so we don't need to write it. Now you see the advantage of doing it this way?
Yes.
I didn't need a number greater than 20. The way you did it, you had to deal with 80. And if you don't have a calculator, the bigger the number, the harder it is to simplify. So it's always a good idea to simplify before you multiply across top and bottom. It's the same thing as, let's use variables. You know how to do these. We had some of these in the thing. If I multiply top and bottom, what do I get?
You get, don't you get, x to the 20th, or would you get...
9. Always do one level less. We've dealt with exponents in this packet, right? Or not?
Not in this packet so
Okay.
much, but he's
Okay, sorry, I didn't realize. I forgot. No, you add exponents, so it's x to the 9th in the top, x to the 5th in the bottom, And now you subtract the exponents, so it becomes x to the fourth. But rather than doing the numerator first and the denominator second and then reducing it, it actually makes sense to start canceling some of that. Turning that into a 2, cancel this, turning that into a 2, and now I just have x squared times x squared, that's x to the fourth. In other words, you can get to the answer in a lot of different ways. You want to get there in the way that uses the smallest numbers. I don't mean just you, I mean everybody. Okay? Now,
Okay.
I don't know whether to... David, you know what I'm concerned about here?
Yes.
Should I go forth to another problem?
Yeah, I think that we should jump around with some of the other problems, David. And then what I'm going to try to do is to work with him as carefully as I can on getting his sheet that he brings in. I don't understand why he just totally freezes up on these elementary things when he's talking to you on the computer. I'm just totally baffled.
Okay.
The other day you did an even shorter cut the last time that we did it.
Yeah, the way I would do this, Patrick, I wouldn't divide by 4/5. I would do it in 2 steps. I would multiply by 5, and then I would divide by 4. Notice that that's the same as dividing by 4/5, because when we divide by 4/5, we end up multiplying by 5/4. Well, that's what I just did in 2 steps. I multiplied by 5 and I divided by 4. So I can get there immediately without having to worry about that problem of dividing by a fraction. You generally don't want to have solutions that involve you dividing by a fraction. Nobody does. All right, let's pick another one here. Number 7. Again, just read me the next line.
Yeah, I'm going to have him actually write it down on a piece of paper,
Okay.
David, then he can read it to you. I think maybe you'll be able to see it better.
Okay.
So, 2x minus 5. Okay. You see it? Yeah, or no, number 7, sorry. 2x plus 8. Okay.
So the first thing you could do is add 9.
Okay.
So it's 2x plus 17 is greater than 5x.
Okay.
And then you could minus 2x
Okay.
from each side. So it'd be 17 is greater than 3x.
Okay.
And then you just divide.
Okay. So what's the final answer?
It's about 5.6.
Well, I didn't mean that. I didn't mean turn it into a decimal. I meant verbalize it.
Yeah, remember he said that when you get to this stage, this is good enough. It's not, it doesn't say on the form that you have to do it, so it'll be 17/3. Well, you can have both of them on there. But the thing is what is the 17/3 is what?
It's greater than x.
All right, let's see, he wants to hear.
I'm going to give you some multiple choices. I want you to pick from which is true. How about those two?
B.
Okay. In other words, you may get a problem like this, and they may give you multiple choices where everything has the x on the left. And the way you solved it, there's nothing wrong with the way you solved it at all, but you ended up with the x on the right. So if you have to switch the two terms, you have to change the direction of the sign, always, irregardless of whether positives or negatives. Okay. About 8. What does this mean?
Number 8.
Yeah. In other words,
That's absolute value.
okay.
So doesn't that mean the answer will come out to both positive and negative?
How do we solve this?
Crap, I'm sure. This is one of the ones I...
Okay. When I said, what does this mean? What I meant was not so much that it means absolute value. It's if you... This means two things. Absolute value always means two things. One of the things goes over here, and I'm going to put an or in the middle, and I'm going to put the other thing on the right side. So what's the first thing it means?
It means that the answers will come out as well.
Well, the first thing it means 3x plus 5 equals what?
14.
Okay, that's the first thing it means.
And
Or
3x
what?
3x plus 5 equals negative 14?
Yes, that's what I meant by what does it mean? It means those two things. And now you solve each one of them separately to come up with x equal 3 and x equal minus 19 thirds. Okay, so it really means x equals 3 or x equals minus 19 thirds. But we can't get to this solution without doing this step first. So that first step is always what you want to do. In other words, once we get this first step, the rest of it's trivial. I know you know how to solve these each. So the question on this particular problem is always, how do we state the first line? And whenever you have an absolute value, that's the case. In fact, let me do, well, let's just do it. I'm sure you have one on here. What does this mean?
That 3x plus 5, the absolute value of 3x plus 5 is greater than 14.
Well, the first thing it means is that, which is not, okay, I'm sorry, go ahead. That's the first thing it means, is that 3x plus 5 is greater than 14. In other words, the very first thing you write is always everything you see, just remove the absolute value sign. So this is always the first thing it means, is take away the absolute value sign. What's the second thing it means?
Would it be 3x plus 5 is less than 14?
You change both the sign and the sign. In other words, you
right.
change the direction of the inequality and the sign on the number. So you always have to do two things to this right-hand side when you're talking inequalities. If it's an equation, then all you have to do is change the sign. It becomes minus 14. But if it's an equality, make it minus 14 and change the direction. So the answer is 6.
6?
Yeah.
We just write this down. What the first thing you to do is just to add 2x.
What's the 2 doing right now?
It's times it.
Okay, so what do we have to do to get rid of it?
Divide it.
Okay. So divide both sides by what?
Negative 2.
What's the next line read?
X is greater to or equal than, it's less than or equal to.
To what? What's that number?
13.
Plus or minus?
Minus.
What's the direction of the sign of the inequality that goes right there?
It's switched.
Okay, so it's, what's it called?
X is greater than or equal to negative 15.
Okay. In other words, there's a couple of things here you got to be careful of mistakes, potential mistakes. One is when you divide by a negative, you got to switch the direction of the sign, and you still have to treat the negative like it's there. In other words, you still have to do 26 divided by negative 2 equals negative 13. And it's easy to forget one of those things. What's the answer for number 9? If you solve that for W.
Remember, you solve for W. So
Here's the equation. V equals LWH. It's equation for the volume of a box. Length times width times height. So how would I solve that for W?
You could divide L. You could divide by L and H to get it over to V over LH equals W.
That's it. Good.
Let me get your fresh one. Just all over the board here. You can start a nice new sheet.
14. How do we tell if that point is a solution?
You just plug it in.
Write it down and plug it in.
Yeah, go ahead and just read the plug-in for me. You don't need to come up with an answer to the question, but plug in what for what?
It'd be 4 times negative 3 minus 5 times negative 2 equals negative 2.
Now expand that.
It would be negative 12 minus negative 10. I mean, plus 10.
Okay, I don't mind you writing it like that. That's not a bad intermediate step. And then change it. You don't want to leave the two minuses together. You don't mind having two pluses together because plus plus equals plus. So two pluses is the same as one plus. Does that equal negative 2?
Yes.
Okay. What's the line x equal 5 look like?
It's a vertical line at 5.
Good. What's its slope?
It's infinite.
Good. Careful using that word around your teacher, though. She might mark it wrong.
So it's undetermined, or undefined, or infinite. So is the preferable term then undefined, David?
Depends on who you're talking to. I would say in algebra, yes.
Okay.
If you ask me, I would much prefer infinity. But infinity says something to me. Undefined means there's nothing they can tell about it. Well, which isn't true. Undefined, there is something you know about that slope. It's very, 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 very large. All right, I have a 7 o'clock, so I am going to have to run.
It's 19 hours.
All right, David, I think we'll catch you then. I think it's 1:30 tomorrow.
Yes, that's correct.
And, you know, I think what we should probably do, David, is continue to either do this or maybe just have you create new problems based on the same.
I can certainly do that. I can make them.
Yeah.
I can make them up even.
Just so that it would give them. I mean, you could look at it and say, look, in my mind, you could put it together a new 37 for us or whatever.
Yeah. At this point, I think I need to do this random testing just so I'll see where he's needs some work. Because I don't know if I know that yet. If you know specifically where he needs work, or if he knows, then let me know and we'll focus in on that.
All right, David.
Okay, I'll talk to you tomorrow.
Talk to you tomorrow.
Bye-bye.